谁是兽女？你是兽女？谁是兽女？你是兽女？你呀？你刚才跟我说没有啊？兽女，文硕，OK，硕，记错了啊，一个字，是什么？有有 Attendance later what?
No, because when you finish.
Oh, okay. We'll take it later. It's okay.
I'm not going to leave you.
I know. I mean, I I I haven't decided how I took it today. Yeah. I mean, if it's enough people, then maybe I don't need to ask you. But if you really determine you want to start earlier, maybe come like the second or third hour. Yeah. Yeah. Maybe. Okay. Good afternoon. How you guys are back from your holidays? I think we should start soon. Today we got an aim. We need to at least finish the area of holograph to do the question in the assignment, right? Okay. So hopefully we'll finish that. Okay. In a random scoring of a page, I saw this meme. Yeah. I hope you guys at some point will learn algebraic geometry. It's a nice topic. That's right. For those that I remember, I think I only got 12 of you. Yeah, 12 of you. I discuss with me the topics. So I want to by this Friday, everyone should give me a topic, whether you discuss or not. Okay. If you give me a topic and then you decided to change, also can. But this Friday, you must give me one topic. Okay. I will collect all the topic by this Friday. And you will only have 1 month left to write your project. And then between this month, you can within this month you can send me your draft, and then I can help you to check if there's anything to change. Okay. If you don't want to have any help from me, then we will just grade your project straight at the due date. And I will give you a Turnitin link. You can upload your draft there and see if there's any plagiarism. Okay. So we will refer to the plagiarism rate given by Turnitin as well. Yeah. Any question from you guys about lectures or so? So next Friday is the test. Okay, is the test. So we'll have it on Friday, about 1 hour test. You also need to come on what time is it? Our class 11, right? Okay. So if we finish earlier, then we'll break off earlier. Yeah. So everyone should also come at 11. 11. Yeah, 11. Yeah, you're allowed to bring cheat sheet, calculator, okay. 2 double-sided A4 page cheat sheet. Okay. Yeah, you can bring all your formula theorem into the test. Anything you want to write on the cheat sheet is okay. Just one double page A4 size. Okay. Okay, speaking of this algebraic geometry, right? So let's start with how we started with Cartesian coordinate, and then we'll talk a little bit about parametric curve that we have learned. Okay, so and in the ancient time, there's really these Greek or Babylonian people. They look at a triangle or circle, right? Remember how we define circle first? It's an equidistant point from a point. Okay. At that time, we don't really have any coordinate. Okay. And later, so this I should write here. This is a geometry. Okay. Later, so Indian people or Arabic people come in. Arabic. So they are working on this algebra stuff, playing around with XY, right? Algebra. For example, the number you use today are Arabic number 1, 2, 3, 4, 5, 6. Okay. So they are good at this. And in the middle of the time, so these two get married. Okay. So who married them? Exactly what I mentioned last time is the French mathematician or philosopher, René Descartes. Yeah, that's why we have this Cartesian coordinate named after him. You can notice in mathematics, right? if we use the name of people, if it is what's the convention? Either we use the full name, either we use as an adjective, and then one of them will capitalize it. So we have these XY coordinate with the geometry. Although this is the marriage between algebra and geometry, we don't call it algebraic geometry. Okay, we call it analytic geometry. Algebra geometry will be another branch of studying this algebraic curve. By the way, if someone wants to write about these big topics, right, like algebraic geometry, and then in classes I also mentioned something about Riemannian surface, you can write on this, but because this subject is kind of deep, so what you need to do, you can show that some object we learned in this class are actually algebraic object or Riemannian surface. That's all. That's enough. Okay. If you want to write on this big topic, you don't need to go deep. Okay. Okay. So why I talk about this? Okay. So let us look at these two different way of describing a unit circle. So analytic geometry here, we are looking at infinitesimal calculus. Okay. So we have at least two ways to describe the unit circle now. So first of all, we can describe as x squared plus y squared equals 1. And then we can describe it as a parametric curve. Yeah, I spelled it wrong. Parametric curve. So anyone remember what's the parametric equation to describe a unit circle? X equals to cos t, sine equals to y equals to sine t. Okay. Okay. So sure. So let's look at these two. Okay, so we look at these two. So analytic geometry, we study the infinitesimal calculus on the geometry. Let's say what? Which point I want to pick? Let's pick this point here. Call it 0, 1, right? Let's look at this point, and then we look at the tangent line here. Okay, we look at the tangent line here. So last time we learned how to do dy dx on parametric curve. Does anyone remember? How do you find dy dx using parametric equation? Dy dt on the dx dt. Good. Okay. So in this case, what do we get? We get cos t over minus sin t, right? Okay, which is what? Minus cotangent. Okay, minus cotangent t. Oh, sure, yeah, cotangent t. I'm not sure this is helpful or not, but leave it as this. On the other hand, Venus asked that can we just straight away differentiate the function or not? Sure, we can straight away differentiate the function. What function we need to differentiate here? X squared y squared equals 1. How do you differentiate that? Over x? Implicit. Ah, implicit. Okay. I mean, let's not do implicit. Okay. How do you get the function over that point? Hello, boss. Enjoy it. Have a coffee. No, just have a look. Okay. So yeah, can you get a function at that point? I mean, around that point. Can you get an honest function? I mean, y equals to square root y minus x squared. Okay. So let's fix this y in between 1 and greater than 0. Okay, for our purpose, we don't really care outside this range. So it's like we ignore this part here. Okay, we ignore this part. And we just look at this upper hemisphere. Right? Does it make sense? Does it make sense? Does it make sense? Yeah. Oh, no, not so good. Huh? Okay. It's okay. And by the way, who is the guy for Chen what? Chen Zhixian. Oh, you have. Okay, okay, good, good, good. Finally, I saw you in person. Okay, good. Yeah. Any request you want, you can just point out. If we can give, we will give you. Okay. So, right. So we look at this. Okay. This is the upper hemisphere. So we differentiate this, right? So we do dy dx also. What do you get? You have chain rule, right? Okay. So with the chain rule, what do you get? What? Do you want me to do the differentiation? What do you get? Differentiate square root 1 minus x squared. What factor do you get first? What factor do you get? 1 over 2. Okay. What else? Negative 2x. Then what do you left with? To the power minus half, which is 1 over square root 1 minus x squared. Okay. Also, what do you get? X over square root 1 minus x squared. Does this 2 look the same or not? Is it the same? Same or not? Sorry, I missed my minus. What is the bottom part? The bottom part is x over y. Right? So tangent, what's tangent t here? Tangent is the angle here. Okay. So your x and y is the horizontal component and the vertical component. So, okay. Can you see the equivalence here? Can one see the equivalence? Or I write tangent t equals to opposite over adjacent 1 over x So cotangent is upside down. So x over 1. Okay, and here also you can see how the trigonometry integration comes in, right? So this is where they discover the trigonometry integration. Okay, make sense? Okay. So you right. So when you do trigo integration, right? Something whenever you see this kind of thing, you want to substitute to some polar coordinate cosine. Okay, this cos we can go between polar coordinate and xy condition. Okay. 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 I'll go a little bit faster so you get my tempo already. So you just point out any question or any mistake I made. Then we can go through it. Okay, but right. So with last time. So last time we have the third description. Which is the polar curves. Okay, polar curve. So what's the equation for the polar curve for a unit circle? Anyone recall? Standard. Okay, very important here. This is just not just a unit circle. This is unit circle centered at origin. Okay. So you need to tell me what's the center and the radius every time you talk about circle, right? Because if you change the center, then it will shift the equation. Okay. So what's the polar curve for this? Huh? I group 1. Okay, good. So it is r equals to 1 for unit circle center at origin. Okay. Yeah. Okay. I think hopefully later we also will learn dy dx in terms of polar coordinate, either today or tomorrow. All right. So let's go to polar curve now. So let's do another example. Okay, maybe I don't show you how to draw this. Later I'll show you the other one. So let's say we want to draw this r equals to 2 cos theta. Okay. So r equals to 2 cos theta. So one primitive way you can do is you go and test number. Okay, test some number and then see what radius you get. And then you plot it on the xy plane. Okay. Not that this this plane here is a xy plane, but this table here is in terms of radius and angle. Okay, radius and angle, right? So you still remember how you find radius and angle in the xy plane? You still remember? So 0 degrees start from what axis? Huh? Positive or negative? Polar axis. Well, yeah. So my question is, what is the polar axis? Yes, positive axis. Okay. So we start from the positive part. Okay. Because we also can choose negative part, right? Okay. But our convention is start with the positive part. Okay. And then from here, turn anti-clockwise. Okay. The degree increase from 0 to 2 pi. Okay. So 2 pi, you come back to the same point. Okay. And then radius is along the polar axis. Okay. So what can you see here? So when theta is 0, radius is 2. Okay. So at the 0 degree, you have radius 2. Okay. And you can see that while this theta increased to pi over 2, okay, which is 90 degree, what happened to the radius? What happened to the radius? The radius decreases. Okay, so when you increase in angle, this radius, right, become shorter and shorter and shorter and shorter and shorter until you get to the 0 point. Okay. Can you all see the radius decreases? Okay. And then what happened next? So what happened next is you can see that the angle increases, but increase in a negative direction, negative radius. Okay. So where is the angle pi over 2 to pi? Which quadrant it lies? Which quadrant for pi over 2 to pi? Second quadrant, right? So if it is positive, you should draw it here, right? When the radius is positive, you should draw it here. But when it is negative, remember what we said last time? So this is equal to what? This is equal to r theta plus pi. Okay, so instead of positive radius, you need to take the opposite counterpart. Okay, so let me draw something for you. So let's look at uh, this point here. Okay, look at this point. Okay, so if it is 1 and 2 pi over 3, okay, this part you are given -1, 2 pi over 3. Okay, so you need to go to the opposite of this line. Okay, and take 1 uh, plus pi is what? 2 pi plus 3 plus pi is what? Is equal to 2 pi plus over 3 plus pi is what? 5 pi over 3. Okay, so 5 pi over 3 should lie in the fourth quadrant. Is that right? Okay. Okay. So you keep doing this for every angle between pi over 2 and pi. Okay. So you can see that this 2 here finally meet up with this 0, 2 here. Pi minus 2 meet with 0, 2. Okay. In this case, you can see that if you keep going, okay, if you keep going until 2 pi, you can see that you're just repeating, getting this circle here. Okay. So the fundamental interval is from 0 to pi. So from 0 to pi, you can plot everything out. Okay. Okay. So another way to see this circle, right? There's another way to see this circle. Okay. So let's write this down. R equals to 2 cos theta. Okay, so there's another way to see this circle here without drawing it. So how do you show it? I want to show it algebraically. Okay. So we need to turn it back to a Cartesian form, Cartesian graph. Okay. So we know that we can go between. Okay, let me write down Cartesian and really we need to put Cartesian xy coordinate. Okay, and then go between polar coordinate. Okay, what do we do? We have this x equal to r cos theta and y equals to r sine theta. Okay, so we know that r equals to 2 cos theta. Okay, how do we get equation between x and y? And yeah, What else we know? So we know x squared plus y squared equals to r squared. So can we do anything? Which both equation? These two. And then isn't it what I did here? You want to sum it out or? Okay, yeah, okay. So yeah, sure, yeah, sure. So we got this, right? This is a circle centered at 0 origin with radius r, right? But we don't want, we just only want xy variable. Okay, we don't want extra variable coming in. We don't want this extra r. Is there any way to remove this r to see? Because just now I show you that this is a circle, right? So there should have some circle equation coming in. Okay. So can we remove this r? This is algebraic, so you should think substitution. Huh? Multiply r? What do you mean? Multiply where? So you need to tell me where to multiply, right? Okay, so it means let's modify this equation so that we get r squared equals to 2r cos theta. Is that what I mean? So what's the benefit of doing this? You don't need to deal with square root. Um, I think there's a more reasonable uh, reasonable reason, right? Huh? Substitute what? Wait. Slow down a bit. So we got this. Okay, what do you do next? Equal to 2x, right? Because this part is x. So we can make this equal to 2x. Okay? So in this case, we successfully remove this r squared and become something in x, right? Okay? So is this uh, looking more plausible now, like a circle? Does this look like circle? How? Venus? Hmm. Can describe it if you. Oh, factorize. Uh-huh. I think almost got it. Yeah. Okay. Okay. Yes. 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 That's right. So you can completing the square. Okay. So how do you completing the square? You can plus 1 minus 1 y square equal to 0. Okay. So you found the root of your x polynomial. Is this the one? Okay. Which is x minus 1 squared plus y squared equal to 1. So what kind of circle is this? Huh? Center at 1, 0 with radius 1, which is a unit circle. Okay, so that's why you can see that this circle like move to the left right side of the origin. Okay, center at 1, 0. Okay, so this proves that what you draw is correct. Okay. Okay, so there's another thing I want to mention here before we go to go to more example. Okay, so what we have done. Okay, so always remember what kind of setting we are living in. Okay, so we are living in the XY plane, but it is really the same curve. Sorry, it is really the same curve we are looking at every time, even though we switch between polar coordinate or the Cartesian coordinate, right? Okay, so maybe I use blue. Might give me eclipse. Okay, so I'll make it blue. Blue. So let me label 1, 1, -1, -1, 1, 1, -1. Okay. Okay, I'm about to show you one thing. So how we draw this graph, right? So first we describe this as s squared plus y squared is equal to 1. And then we also describe it as I equals to 1. Right? So how we really draw this curve? Okay. So one technique is you can look at the r theta plane. Okay. So you change your Cartesian coordinate into r theta instead. Okay. So what do I mean by this? So I want to look at the curve r equals to 1 instead. Okay. But the label here is theta against r. Wait. R against theta. Okay. But what we did before is y against x, y against x. Okay. So when you draw on the r against theta plane, what is r equals to 1 look like? What does r equals to 1 look like? Similar one. You sure? It's a constant function, right? R equals to 1. I'm drawing r equals to 1 for r against theta. So whatever theta you give me, okay, it is always 1. Right? Okay. So this is a constant function. So what's the lesson here? The lesson here is you need to be alert to what axis you are using. Okay, you need to be alert to what axis you are using. Okay. So what is happening here actually? Does anyone can see or imagine? Okay. So if we take this 0 to 2 pi, this length here, okay, this is always 1. And then we move it to xy plane, right? Okay, we move it to xy plane. When it is 0, it is 1. When it is, for example, pi over 2, it is also 1. Pi over 3 also 1. 3 pi over 2 also 1. 2 pi also 1. Okay, you can see that if you cut this line here, it actually wraps around the xy plane. You see it? You see it? You see it? Okay. So when you go over 2 pi, right? What happened? If you want to map it back, so you just, because we say that every angle plus 2 pi is the same as, so wait, let me write this down. So we identify theta with theta plus 2 pi. So that means you do the wrapping again. Okay. So when you go along this line, you wrap this circle infinitely many times. Okay. If you go negative direction, you wrap the other direction. Okay. You see it? You see it? Any question? Okay, actually, this is a topic in algebraic topology. if someone want to read about this or write about this. But what I want to say is, but the important thing for this class is, you can see that this r theta plane, right, is much bigger than the xy plane. Okay. Yeah, it's much bigger than the xy plane. In fact, what? We just only need this part to describe everything in the xy plane. Every point in xy plane lie inside this half infinite strip, I would say. Yeah. For the other, you are just repeating. Okay. Yeah. So how you see this? Because our xy or the R2 plane is the technical term is stratified, or you can see that this space break into infinitely many circles of positive radius. Okay, and then this line lies in this infinite strip. If you don't get this, it's okay. But what I want you to get it is, you can see that even though the angle keep increasing or decreasing, you might get the same shape. This is what I want to say. Okay, okay, let's see more example. So next example is this r equals to a plus minus b cos theta, or a plus minus b sin theta. So a, b are some arbitrary constant. Okay, so for let me, for some for all, not for some, for all constant. Okay, since we are in a math class, so let's use real. So for a, b in real. Okay, so this graph, right, we call it a limaçons. Okay, so limaçons is in French from Snell. So why is it Snell? So you can see that if you adjust the parameter a and b, right, it look like this. Okay, for example, just now we look at r equals to cos theta, which we make a to be 0, b equals to 1. Just now we look at 2 cos theta, right? So here is cos theta. Cos theta, you also get a circle. And then you can see that it introduced this cups or extra loops when you adjust the A. Okay. When A and B are equal, they are called the cardioid because they look like the heart. So do we have this example here? Yeah. So this is the cardioid. This is the cardioid. Okay. Because it looks like heart. So let's see how to graph this. Okay. Use our knowledge of graphing a circle. Let's see. So let's look at one example. R equals to 1 plus sine theta. Okay, let's sketch this. R equals to sine. So what we do is we start with the r theta plane first. Okay, because r theta plane is easy. Okay, we all know how to graph xy curve, xy graph. Okay, so we start with doing that. Okay, so if we were planning to do on r over theta, so the basic curve of sine looks like this, right? Okay. So we want to graph r equals to 1 plus sine theta, which means you move the graph up by 1. So you get this. So let's make some important point. Bit not symmetry. Let me. Let me move this one in. Okay, so here is sorry, here is 0, here is 1, here is 2, and then here is pi over 2 pi, and then 3 pi over 2. Okay, is it okay? Everyone follow this on a sine curve and then shifted one up. Okay, okay, okay. So let's do this on the XY plane. Remember, I keep stretching where we are living, right? So in the end, we want to do it on a XY plane. Okay, so let me make a note here. So let me make a note. So polar curve, right? So in this course, when you see this r equals to 1 plus sine theta, you should understand it as a polar graph or polar curve. Okay. So polar graph live in XY plane. Okay. So how to transform this r theta graph to XY plane? Okay. How do we transform this? So when theta equals 0, what's the radius? 1. Good. So we have a 1 here. Okay. And then pi over 2, what's the radius? 2. Okay. So you can see that the angle I care about most, right, is this turning point of the circle. So 0 pi over 2 pi 3 pi over 2. Okay. And at pi, what do you get? You have radius. Radius 1. At pi. At pi, what's the radius? 1. Okay. And then at 3 pi over 2, what's the radius? 0. Okay. So you go back to the origin. Not that, you see, 0, 0, right, is equal to 0 for any theta. This is something to see here. Okay. Okay. How about 2 pi? You return to 2 pi, what do you get? You return to 1. Okay, good. Okay. So let's see how we join this picture together. So when r equals theta equals 0, the radius grow up to 2 when you reach theta pi over 2. Okay. So how do you join these 2 points? You keep increasing in the radius until you reach r equals to 2. Okay. So you join them like something like this. Okay. And then what's happening between pi over 2 and pi? Okay. The radius decreases. Okay, decreases from 2 to 1. Okay. So the radius decreasing when the angle increasing until you reach 1. Okay. Should I? Maybe I should. So let me draw something like this. So keep increasing. Okay. Maybe I make it more apparent a bit. So maybe let me sketch it. more inward. Okay, so you can see that. Let me draw this. So when you increase in angle, the radius increases. Okay, and then you join this. A bit, yeah. Okay, does it look a bit nicer? Yeah, hopefully. And then from pi over 2 to pi, it decreases until you reach 1. Okay, so something like this, then it decrease. Okay, and then what happened next? So between pi and 3 pi over 2, the radius decreasing some more. Okay, until you reach 0. Okay, so you just keep decreasing until you reach 0. Okay. Then what happened to 3 pi over 2 to 2 pi? It increased again, okay, with the same rate, but up to 1. Okay, look something like this. Okay, so this because this A and B is 1, right? Okay, so A and B is the same, so it looks like a heart. So this is the direct. It looks okay. Does it make sense? Does it make sense? Okay. Okay. Let's look at some more example. So, for example, what if I change? What if I change the period of the theta? Okay. If I change the period of the theta, I'll get some roses, some flower-shaped curves. And then this rose will have n leaf if it is odd, and 2n leaf when it is even. I invite you to test this. Okay, try check this. So let's look at one last example and then we will take a break. So for example, let's sketch these 4-leaf rows. Okay, so we know how to graph it on r theta plane. Okay, so let's do it on r theta plane first. Okay, and then we will see how we transform this graph to the polar graph. Okay, the polar graph. So here is the xy plane, above is the r theta plane. So how do we make sense of this? Okay, so similarly, let's break our curve, our xy plane into a few angle. Okay, few important angle. So for example, okay, let's look at this r theta graph. Okay, when the theta go from 0 to pi over 4, okay, the radius start from 1 and then decreases to 0. Okay, so you start from 1, 0, and then you keep decreasing in radius. Okay, I should show you this. And then it comes in when the angle is pi over 4. Okay, make sense? Let me use what color? Use green. So this is the first part. So what's the next part? So next part is a bit interesting here. Pi over 4 to pi over 2. Which quadrant does this lie? Huh? Pi over 4 to pi over 2. Which quadrant? The first one, right? But the radius is negative. So what happened? Huh? You need to go to the opposite quadrant. Okay, so you need to go to the third quadrant. Okay, so what happened here? So the radius increased from 0
up to 1. Okay, so you need to go to the opposite quadrant. Okay, and then you start from 0, start from pi over 4, the line pi over 4, and then the increase up to pi, 3 pi. Here is 3 pi over 2, right? Pi over 2 plus 3 plus pi. Okay, let me write up. So pi over 2 plus pi is 3 pi over 2, right? Okay, all right. Okay, so we keep going. So what's next? The third part here, pi over 2 to 3 pi over 4. Okay. Okay, maybe I ask someone to answer. Getting more quiet. I think something is going wrong. Ling Sun Ling. Not here. COVID. Okay. Did she or he email me? Huh? Because I didn't receive.
I don't know.
Okay, can you ask he or she? She. Can you ask her to like email me? Huh? Can you ask her to email me? Yeah. Okay. Jingbo, huh? Jingbo is the discipline. Discipline. Oh, this one COVID. Okay, whoever gets it, please email me. Oh, is she the one sleeping? Oh, the sleeping one, huh?
Yes.
Also, she don't know what the disease or is a COVID. She said she's very tired last time.
Maybe.
Maybe. Okay. Let's see someone else. Tanya. Yeah. Oh, okay. So how to graph this third part here from pi over 2 to 3 pi over 4. Okay. You need to plus pi. Okay, good. So because this is negative, you need to plot a positive radius, so you need to plus pi. So where's the region you lie in? Okay, so let me plus pi first. So plus pi, we get 3 pi over 2 and 8. Yeah, 8 over, 7. 7 pi over 4. So you said that this is in the third quadrant. Okay, so this is in the third quadrant, good. And then what happened to the radius? Okay, wait, what radius you start from to where? What happened to the radius? We already know which quadrant, right? This quadrant here. Okay. We also know that it's 3 pi over 2 to 7 pi over 4, which is here. So how do we graph the radius here? Because it's what? Increase. You sure it's increasing? You increase from -1 to 0, but you already make it positive, right? Positive value to 0. Decreasing, right? Okay, so decreasing in radius. So there's some misconception here. Although we say that the radius can be negative, right? In XY plane, really we only care about positive radius. Okay, because every point with negative radius, we can make it into a positive one. Okay, and then that radius tells you how far you are from the origin. Okay, so really we almost every time we talk about radius, we only care about positive radius. We don't care about negative one. If it's negative, we can just swap it to a positive one, right? Okay, so in this case, after we change the degree, this part here becomes positive radius, which is from 1 to 0, right? Decreasing. Okay, so you start from 1, 3 pi over 2 to 0, 7 pi over 4, right? Okay, So we'll continue this line here. Okay, next one. From 3 pi over 4 to pi. I want to ask Sheldon. How do we plot the part from 3 pi over 4 to pi? So first ask you what's the quadrant does it lie? 3 pi over 4 to pi. Huh? First quadrant. Fourth quadrant. 3 pi over 4 to pi. Which quadrant? Over 4 to pi. Pi is what degree? Second, okay. Yeah, okay, good. Second. So it's in the second quadrant. How about the radius? At 3 pi over 4, what radius do you have? What radius do you have at 3 pi over 4? What's this point is? What's this point? 0, right? Okay, so at 3 pi over 4 is 0. At pi, what do you have? 1. Okay, so at 3 pi over 4, you have 0. Okay, at pi, you have 1. Okay, so what happened to the middle point? What happened? Increasing or decreasing? Increasing, right? Okay, so you increase from 0, 3 pi over 4, and then when you go along the angle, you increase in radius. Okay, until you stop at 1 pi. Does that make sense? Okay. Let's see if you can get another one or not. Did I call Yang Liu Qing before? Yang Liu Qing. Is Yang Liu Qing here? Yang Liu Qing. Who's Yang Liu Qing? Yang Liu Qing. Yeah. Yang Liu Qing. You. Okay. Can you tell us how we plot points from pi to 5 pi over 4? Tell us which quadrant to start with. Huh? Sorry, I cannot hear you. So where does pi to 5 pi over 4 live in? Sorry? Sorry, I can't hear you. Which quadrant? Pi to 5 pi over 4. Which quadrant does it lie? Do you know the answer? Do you understand what I asked? Where does pi to 5 pi over 4 live in? Which quadrant? Wait, do you understand what I asked or not? Yes. So first, second, third, fourth answer, which one you choose? Pi is what? Pi is 180, right? 180 to 5 pi over 4 is 125. 205. 25. Yeah, so which quadrant it lies? Oh. Hello, hello. I'm still here. Do you have any issue answering? Okay, so what's the answer? What is it hard to say? Huh? Can you tell me what you are thinking? Huh? Is it so hard to answer? What's the problem? What's the problem? I don't understand. What's the problem? If you have problem, please tell me. Huh? Do you get my question or not? First of all, do you get my question? Yes or no? Yes or no? Yes. Okay. So where does pi to 5 pi/4 lies in? Which quadrant? Can someone translate what she say? I cannot hear. I mean, tell me what she said. She's too soft. Cannot hear also. Okay. Do you want to give an answer? Can you hear what she said? Maybe you ask her. She's too scared of me. You help me ask her. What she said. Don't know how to explain it. Don't know how to explain it. Do you know what is the first quadrant, second quadrant, third quadrant, and fourth quadrant is? Do you get it? So this is the first quadrant, right? Okay, from 0 to pi/2 is called the first quadrant. Pi/2 to pi is second quadrant. Pi to 3 pi/2 is third quadrant. And then 3 pi/2 to 2 pi is fourth quadrant. So my question is, where does pi to 5 pi/4 lies? Which quadrant? Third. Okay, good. So you see, so I think first you don't understand my question. I already give you the choice, right? So this is a problem of communication. Okay, all of you should be the same. Okay. So if you first don't understand what kind of language I use, okay, you cannot communicate with me. Okay, we should have a common ground first. Okay, so when I talk about first quadrant, second quadrant, third quadrant, fourth quadrant, you don't understand what I say, you should directly ask me. Right? Okay. So you see, after I draw this first, second, third, fourth, I straight away like this. Just now I don't want to say. Right? So this is the usual communication problem. You need to get it right every time when you talk. I mean, speak with people. Okay. Both of you should have a common ground first. Then straight away we can get the issue done. Okay. We don't need to wait. Okay, so make sure we have a common ground. So every time what I say you don't understand, you should ask first. And then we have a common ground, then we can discuss. Okay. So the hard thing is not about idea. The hard thing is about communication. Okay. Okay. I let you complete this graph yourself. Okay. Example is already there. See if you can continue drawing it. And if you have any more question, you can pause to me and then we can do it again. Okay, but we want to move on for the next hour. So let's take a break. Take a break until 3:16. We'll go into the next section. Yeah.
R equal to 1 plus cosine theta is
Yeah. What?
is the just a direction.
Okay, there's
I want to
from my direction. And then
I want to rotate this.
you want to rotate.
Yeah, what can I do?
You can rotate much. I think you can only. I think you can. I'm not sure if you can rotate like this without. I mean, you can rotate, but the question is how to rotate. So you want to use matrix, or you want to use minus theta minus r, something like this, right? Okay.
Because I see 1 plus cosine theta and then 1 plus then
Mhm.
theta
Mhm.
is
These
very
are
similar.
two. These are two basic shapes. So if you use cos, you get something like this. If you use sine, you get something like this. So it's like 90-degree different. But if you want to rotate, oh, okay. So yeah. So if you want to like reflect on the y-axis, right? I think you can use minus r,
So
right? And then you use minus r for 1 plus sine theta then theta, right? So actually it is not coincident why this is 90-degree to this. Because in Fourier series, we know these two are orthogonal. Yeah.
Use the rulers of A and B and R periodic with has a period to it. Just this question. So don't want to compute the integral over 0 to 2 pi. I want to compute it from minus pi to pi. Like this.
Then you need to explain.
But
You just explain why you can see it in that way. That's fine if you want. You can explain. You can explain.
like this. Because fx is only 5 and 0 to 2 from the question.
Yeah.
Yeah, and this is the formula for it. And I want to show that this is equal to this, and then I can do it. But I only saw that it only says that A and B had a period of 2 pi, but didn't prove it. And I think it's if there is only one constant like A or B, I can prove it that if anything else is periodic just by prediction. But there are two.
What are you saying?
I mean, if there is only one constant, unknown constant in the this formula, I can easily prove it that this constant is periodic with the fact that everything else is periodic. But there are two constants. It makes it much harder.
What are you trying to do? So why you change this domain to this domain? Why is this easier to do?
Because
Hmm.
then this is an even function.
This is an even function.
Yeah.
This is an even function.
After changing it, but they need the fact that an is periodic is as a period.
But I still don't understand why you. Why?
Just I can't show that an has a period 2π, but it's
an. I mean,
I can't prove it.
an is a coefficient. Why an has a period? An is just a number. Why a number has a period? Okay, I mean, it's a constant number. Why is there a period? I mean, the period is anything, right? Because it's constant. Are you talking about the coefficient has a period? I don't understand. You get what I mean? An is just a constant.
Okay, it's on book that.
你们把这个图画出来了没？
是可以直接带那个。
可以是可以，但是你要考虑到它可能不 intersect。啊。
跟它 intersect 的话，我们要写什么？
啊，对，那个是对的，那个没有问题，那个没有问题，那个没有问题。可是这个 intersection point 是什么啊？哎，因为我是一开始是想说这个跟可能 graph 之间可能会 intersect，但是我是说那个 graph 会跟那个 xy 的，哎，就是这样，就是。它也会 intersect 这些 point。对对对，我没有特别指那个 intersection point 这样子。
intersection point 是我可能是
画个。
有毒，
有毒哎！我不知道我自己放的有毒哎，
够毒了。
我不知道我自己放有毒。
Just actually proving the statement in proving the problem for you.
然后他讲，知道我画的。喂。
现在明天来赶工。Okay, so this periodic is talking about this function inside, right?
Yeah.
Okay. Yeah. So.
But in the question, fx is only defined on 0 and 2π. It's not periodic. Oh.
You mean that's not periodic because I define on 0 to 2π and then I extend, right? So it's periodic.
But that's not extend. You said that
What did I say?
the period of the Fourier series is 2π, but you didn't say anything about the original fx.
I mean, this implies.
Questions?
Okay, I mean.
This
is implied. This should be implied because when I talk about period, right? If you don't extend it, where is the period? So I mean, it should be like 0 to 2π is like this, and then if I say period, then it means the expand part.
I was going to give you just that one term only.
One term.
The term between 0 and 2π. Because your Fourier series is.
I can use the big Fourier series just to estimate the function on this.
I mean, okay. Okay, do you accept that if I say when I talk about period, then I mean extending this to everything? Yeah, that's what I meant.
But from my understanding is I need to use a Fourier series with the period 2 pi to represent this function from 0 to 2 pi. I understand it that way.
Yeah, that's correct.
But that doesn't change the facts because
Does it change? Yeah. So what's the problem? I don't know what's the issue.
So Fourier series is basically the series where you have this term plus this, which is basically different intervals, right?
I think you can understand it that way.
I understand it in that way. That's why I like, because you only want 0 to 2 pi, that's why I just give you this term instead of the whole.
I mean, this is a short way.
So that was my first thought process lah.
Okay. Because if it is in that case, right, I don't need to talk about period. There's no period to talk about, right? It's just one thing. If I talk about period,
Then I guess it's the understanding of the
over time should be repeating, right? That's what period means. Maybe a bit short lah, this question. I mean, a bit succinct, but
So basically, you just want the Fourier
just
extension.
some easy
of,
question.
okay,
I'm not doing something.
just calculate the extension of this
Yeah.
in this period. Okay.
Yeah. That's all.
just change the interval.
You can change, but
to
you
another
just
period.
explain why these two are the same function, and then you can change it. Actually, you see, I want you guys to use this remark here.
First and too long, so we skip. No, one and two question.
Oh, yeah. This is question 1.
Okay. I mean, yeah. There's relation sometimes.
So about the test next week.
Yeah.
The
You have to ask the up downstairs.
Okay.
Let people hear.
I can use computer to graph it.
You can use computer to check it. Okay, someone asked question 5 in the assignment, can you use computer to graph it? So the answer is cannot. But you can use computer to check your answer. What's the other question? Huh? Exam scope? Up to, okay, I can safely say up to area of polar graph. Yeah, this one. Okay. I said 5 questions. 5 questions. How many? No. Do you think it's possible? We got some got some questions. How many group? I cannot quite. You guys can be more mature a bit. You want me to give you the exam paper now? Please learn how to find boundary. Okay? Find boundary. But for sure, for very sure, you have proof question. Okay. Yeah. For very sure. So if when you try out the tutorial question, right, review question or homework question and left, if you cannot get the idea, do not know how to start, just send me. Okay, just send it to me. Okay. Or you want me to check, also can you send it to me? Okay. So that if I see that there's something that everyone should know, then I will bring it up. Is it clear? Yeah. Okay. But please do the exercise. Okay. Please do. Don't think that you don't do, then you will know. Okay. It's a kind of impossible unless you are a genius. Okay. Yeah. Please do. I know you all are grown up. I won't force you again. So please do. I need to beg you to do. Okay. Okay, there's some question here. Maybe I just left it. Okay. Another thing is if you check that the question I did in the lecture and then the previous year that I don't mention or what, you can ask me. Okay, see if I how to say, if I miss it, or if I actually I don't how to say, I don't just don't want to do it. I mean, not just don't want to, I mean discard. Yeah, discard. Some example maybe I discard. Some example maybe I miss it because there are different version of lecture notes sometimes. So I just dismiss it accidentally. Okay, not purposely. So anything, any discrepancy you found, right? Just email me. Just let me know. Okay. Is it okay? Okay. Okay. Yeah. So for example, last time Jimbo messaged me, right? So he messaged me, you haven't paused the homework solution. Yeah, right. I haven't paused because I just updated the file in my notes. I forget to upload it. Yeah. So just let me know if you found anything different from what I say and then from what I post. Okay. Yeah. Also extra question you also can ask me. Okay. Just don't be shy. Okay. If you are shy, then you are the only one that suffer. Don't have the post. Okay, so 3:25. Let me see. Enough time. Okay, we should have enough time. So let's do dy dx on the polar graph. Okay. So as promised just now, we start with polar graph in tangent line on polar graph. Okay. So is there any way when we find dy dx, but on the right hand side is something in terms of dr d theta? Okay. Is there any way to do it? Is there any way to do it? What's the equation link between x, y, and r theta? Remember? Okay, this is the second time we repeat this construction. So what's the equation link between x, y coordinate and radius and theta? How to go from Cartesian coordinate xy to polar coordinate? X equals to r cos theta and y equals to r sine theta. Right? Okay. So last time we know that dy dx, if we have this parametric curve here, we have dy dx equal to what? What? Dy over d. In this case, y in terms of theta, s equals theta, so we change to theta. Dy over theta over dx over theta, d theta. Okay? All right. So how to differentiate y with respect to theta now? Okay, how you differentiate y with respect to theta? Any idea? What do you get here? Answer? R cos theta. Is that all? Who agree? Who agree? I mean, who disagree? Okay, who disagree? Okay, who? Ming Xiu disagree. So why you disagree? Okay, what do we start with? We have R in terms of theta. So R is not a constant here. Okay, so you have two product of two function in theta. So what do you do? What should you do? Product rule. Okay, which you get R cos theta plus d over d theta R and then sine theta. Okay, so you can see that you get an extra term, okay, in the product rule, right? So let's put it down. What do you have in the numerator? So you get d r over d theta sine theta plus r times cos theta. Okay, so really, if I'm pedantic, I should put this r in terms of theta. Okay. So you can similarly guess that dx theta should have a similar form, right? So you do the same computation where you will get similar computation, wouldn't say the same. You get dr over d theta cos theta minus r sine theta, right? Okay. So you just differentiate this function here. So differentiate cos become minus sine. So you see, so this is the third description of your dy dx. Okay, when your function can be expressed as a polar graph. Okay. Should we do an example? You guys want to do example? Okay, maybe let's do example. Okay. So quickly run through this example. This is similar to what we have done before. So let's consider the r equals to 1 plus sine theta. Anyone remember how does this look like? We just plotted 30 minutes ago. How does this look like? Cardioid. Okay, so how does this heart facing? Like a pitch, sure, like a pitch. So the pitch is upside down or to the left, to the right, to the where? What's the direction? Down. Okay. So what's the part at the bottom? Like a peach. You like to eat peach, is it? You like to eat peach.
I am not.
Oh, okay. 孙悟空 okay. Yeah, peach. Okay, so let's find the slope. Let's find the slope or the tangent point. Okay, tangent line or slope. Tangent line at theta equals to pi over 3. Okay. So I want to prevent you just seeing this question and then go dive into use the formula. So what's this question asking? Where is theta equals to pi over 3? Which quadrant? First, okay, don't look at me and give me answer. Pi over 3, okay? So somewhere here, I just simply pick one. And then we want to find the tangent line. Okay, find the dy dx. Right? So what do we have for the formula just now? Should we just copy this down? Let's bring this down. Yes. Is it weird that why we start with a polar curve, but we are writing dy dx here? Is it weird? Not weird. Why? Venus, why? You already learned the connection. Okay, you already learned the connection. Sure. So what is happening for this polar graph? This polar graph is living in a xy plane. Okay, so it's living on an xy plane. So we should be able to write it in terms of function. Okay, combination of function. Okay, because it can be a function, right? 1x, you have 2y. Okay, so but you can restrict the curve such that you get a function here. Okay, remember what we did for unit circle just now at the start of the class? Okay, that's what you should do if you want to find y of x at around this point. Okay, remember the unit circle we did in the start of the class. Okay, any question? I see some confused. Okay, never mind. Let's keep continue. Okay. So now we want to differentiate r with respect to theta. What do we get? It is just how to differentiate r with respect to theta. What do you get? Cos theta. So the first term disappear, and then you differentiate sine theta, you get cos theta. Okay, so what you get is cos theta sine theta plus r cos theta over cos square theta minus r sine theta. Okay, but you can see that we still got r, but we know r in terms of theta, right? Okay, so what's r in terms of theta? R equals to what? 1 plus sine theta. Okay, so you can write everything here in terms of just theta. Meaning what? Meaning you give me every angle, okay? I know the every line here. Okay, I know every tangent line at any angle. From this equation, huh? Plus, huh? Okay, good. Good. Okay, so you can see that we can express dy dx in terms of just theta. Okay, so if you do some simplification of this, you could get cos theta times 1 plus 2 sine theta over 1 plus sine theta 1 minus sine theta. Okay, so you know for every theta what is dy dx. So now we just want to fix it at pi over 3. Okay, so which we get minus 1. Okay, of course you need to go through the substitution step. Right, just write down for you to check if you want. Okay. Okay, so this is the slope or the gradient. Do you guys know how to find the tangent line? If the question asks for a tangent line, you know the gradient, you know a point, how to find the line. You know a gradient, you know a point on the line, so how do you find the line? So let's test you. So what's the tangent line at this point? Okay, y minus the y point. Okay, equals to the gradient multiplied by my Okay, so in this case, what's the x1, y1? What's that point? Okay, so okay, so what? So we got these, right? Okay, so we should have these two, right? This is a chain of coordinate. Right? So we know the angle is at pi over 3. Okay. Do we know the radius? Radius equals to 1 plus sine theta 1. Okay, which is what? Root 3. Root 3 over 2. Okay, I believe you. Root 3 over 2. Wait, 1 plus or after 1 plus or before 1 plus? Before 1 plus. Okay, so we still have 1 plus root 3 over 2. Right? Is that right? So we get 1 plus. Others, please check. Is this root 3 over 2 sine pi over 2? Okay, so in this case, x1 is just 1 plus root 3 over 2 times cos pi over 3, and then y is equal to 1 root 3 over 2 sine pi over 3. What's cos pi over 3? Half. Half, I believe you. So half pi 1 plus square root 3 over 2. Sine pi 3 over 2, I already know just now. Already told me it's root 3 over 2, so I just put root 3 over 2. Okay, so then you just substitute these 2 points into your line equation. So y minus root 3 over 2 times 1 plus root 3 over 2 equals to minus x plus half 1 plus root 3 over 2. So you can combine them. If you want to combine them, you could. So what you get is 1 equals to minus x. So plus 1 plus root 3 over 2 times 1 plus root 3 over 2, which is 1 plus root 3 over 2 squared. 8, wait, sorry. So it's just, sorry, not square. It's 2, wait. Yeah, right, square. Square, all right, yeah. Okay, so this is the tangent line. Okay, okay, next, B. So let's do the next part. So find the point where the tangent line is horizontal or vertical. Okay, this should remind you what we did last time, right? Okay, so horizontal tangent, what do you have? Horizontal tangent, what do you have? You need dx over dt is 0, but dy over ddt is not 0. And then vertical tangent, what do you have? You have dy. Hey, did I make the wrong way? Wrong way, huh? Okay, yeah, wrong way. So dy d theta, dx d theta, and then bottom is dx. Equals 0, but dy d theta is not 0. Okay, this one make more sense because when it is horizontal tangent, right? So you are not going up anymore, but you are going sideways. Okay, but vertical, you are not going sideways, but you are going up or down. Okay. Okay, so what is dy over d theta? So have we computed this yet? Have we computed this? Not yet. Okay, so what is dy over d theta? What is dy over d theta?
What's dy over d theta?
What's dy over d theta? Y equals to r cos theta. Sorry, r sin theta. So what is dy over d theta? Ah,
1, 2, 3, 1.
sin theta plus cosine theta. How do you get this? How do you get this? What? Oh, I mean, what rule you use? Y equals to y equals to 1 plus sin theta. Oh, okay. So you mean you substitute? So you mean you substitute r equals to 1 plus sin theta over sin theta? Okay. Sure. And then you just differentiate y with respect to theta. And sure, can work this way. So can you differentiate? How do you differentiate sin square theta? You can't, right? You need to use trigo rule, right? Huh? Can you just differentiate sin square theta? Yes. Can just bring the power down. Chain rule. Sure. Okay, use chain rule. Let me move this guy out. So you get cos theta plus 2 cos theta. Wait, let me see. What's the chain rule is? Okay, chain rule is another term. So sin theta. Is that right? Wait, let me see. Is that right? Is that right? Yeah, okay. Okay, sure. Okay. So this is what we got. 1 plus 2 sin theta. Okay, so we need to set this equal to 0. So set this equal to 0. So what theta we have? What theta we have? So cos theta equals 0. And then sin theta equals, or sin theta equals to a minus 1/2. Okay, so in this case, what do we have? What kind of theta you have? Huh? What kind of theta you have? Power 2, sure. And then, any more? Power 2, sure. Any more? 5 pi over 2. 5 pi over 2 for which one? For sine or for cos? Over 2. Oh, you mean, okay, I mean, let's see. So we identify pi angle. Okay, so we identify, sure, okay. Okay, so there's some subtlety here, right? You can just add 2 pi to every angle. Wait, let me think. Pi? Maybe you just add pi. Add a multiple of pi to pi over 2 will solve cos pi equals 0. Is that right? Okay, let me draw out what I want to say. So yeah, so there's some subtlety here. So let's do it a bit carefully. Okay, so since this angle, right, can go from negative infinity to infinity, so you can see that there's an integer point of them satisfy this cos theta equals 0. Okay, does it make sense? Okay, so if actually you have infinite solution to it, but which solution we care about from now? For now, we only care about point with from 0 to 2 pi. Okay. Okay, one reason is this curve here will repeat the shape after 2 pi. Okay, this is the one of the reason. Second reason is, remember that in polar coordinate we identify theta and theta plus 2 pi. Okay, yeah. Okay, so depend. Okay, really. So really, you need to depend on what's the shape of this polar graph. Okay, you can see that after 2 pi here, the shape repeat. Okay, but let's say this shape doesn't repeat, maybe something like this. Okay, this is what I gave to the other class as a quiz. So it keep spiraling, then you might have an integer point. Because every angle represent a different point in xy. But in our case here, after 2 pi, okay, it repeats the point. Okay, make sense? Huh? Okay, so when you solve this question, right, so you need to ask yourself, what interval this shape makes sense? Okay, so when you try to do the tutorial question in the textbook, I think they will ask you to find interval such that you can draw the whole curve up. So you need to decide your own interval. Okay, make sense? Does this make sense? Okay. Right. So in this case here, so we only care about theta from 0 to 2 pi. So these are the only 2 points here, because you can see from this curve, from 0 to 2 pi, there's only 2 intersections. Okay, how about sine theta? Okay, maybe I just give you answer 7 pi over 6 and 11 pi over 6. Okay. So I think, should I remind you, there's another, like one way to, there's a way to memorize these, where the quadrant live in. The all science teacher are crazy. Does everyone know this? So if you have a positive value for your cos of sine angle tangent. So all means so let me write this down here. So for all you get, so let me put this as a theta here. So sine here is positive, sine theta is positive, tangent theta is positive. Okay, all signs. So signs mean only signs is positive, right? In case I remember wrong. So only sign is positive, and then cos is So let me move a bit further. So what I mean is pi minus the theta is, so the theta here should lies in here. So here is positive and pi minus theta is negative. Tangent pi over minus positive. Sorry, negative. Negative, positive, negative. Okay. And then similarly for this one, okay, you have that tangent pi plus theta is positive, and then the rest is negative. So I want to repeat the angle. And then for this part here, only cos is positive. Okay, the rest is negative. Okay. If you don't want to memorize this, you can memorize the basic graph if you like. Okay. All right. So similarly, you can do it for vertical tangent. Okay. So straight away give you the answer. The method is the same. So what do we get here is 1 plus sine theta times 1 minus 2 sine theta equals 0. Okay. And then this will give theta equals to 3 pi over 2 pi over 6 and 5 pi over 6. Okay, so there's something happening here. Okay, there's something happening here. So we got these two angles repeated. Okay, so at this point, both dy d theta and dx d theta are 0. Okay, so we cannot really deduce anything, right? Because we need to make sure one of them is positive, one of them is non-zero, the other is 0. Okay, so there's something happening here. So what should we do? So let's collect what we have. So let's collect what we have. So for horizontal tangent, we actually have 3 points here. Okay. So at where, at what angle is pi over 2, 7 pi over 6, and even pi over 6. So if you do substitution using our curve, you can find the radius. Okay. Which I straight away give you first. So just I want to demonstrate where's the point. You can check it later. I just want to demonstrate where's the point and graph out the graph. Okay, so these are the points. Vertical, there are 2 points. Vertical tangent. There are 2 points. Theta equals to pi over 6 and 5 pi over 6. Okay, so if you sub it back to your equation, you will get 3 pi over 2 pi over 6 and 3 over 2 5 pi over 6. Okay, so for the moment, you don't need to care how I compute this. Okay, you just need to know how I get it, but whether it's correct or not, you can check it later. Okay, so we have this 5 point here, but at 3 pi over 2, what do we have? We have dy d theta equals 0. Also the dx d theta equals 0. Okay, so in this case, right, we cannot conclude anything. Okay, we don't know whether it's a horizontal or vertical or something else. Okay. So we need to treat differently. So how do we treat differently? This time we really need to go and see what is dy over dx. Okay, directly do on the xy plane. Directly look at the change of y with respect to x. Okay. So there are 2 ways we can approach dy dx. we can go from the right and go from the left. And then if these two agree, then only the limit, the dy dx exists. Do you guys learn dy dx using limit or not? Using limit, left and right limit equal. Okay. Okay, maybe I just demonstrate it and then we can check it again if needed, the technical detail. So we need to find dy dx from the left and dy dx from the right, and then see what is going on. If I write dy dx here, is it a bit not technical? Okay, I just give you an idea first. Let's write something wrong. Okay. So what to do? So actually not wrong. Okay, so what I'm doing is I need you to imagine something. So what I need you to imagine. So you got a point. Let's call it 3 pi over 2, right? Okay. So you have some curve, maybe something like this. Okay, something like this. Okay. So I want to see how this tangent line behave. Okay. When I go close to the 0.3 pi over 2. Okay, from the left and from the right. Okay, this is what I'm doing. Okay. Okay, so this is kind of weird, right? I put limit for angle, but here appear y and x. Okay, so we need to relate back y and x to angle again. Okay, so how? dy dx equal to? I think it's the same question we started this question. So dy dx equals to what? How to turn it back to expressing in terms of theta? Use product rule for both y and x and divide. Product rule. Chain rule, chain rule, is it? Isn't it? Do you mean this or not? What's the product rule you mean? What's the product rule you mean? Above one? What do we do above? You mean how to compute dy d theta, is it? Yeah. But we haven't reached until this step yet. We're still at dy over dx, right? Okay. So we need to go from dy over dx to dy over d theta and then dx over d theta first. Okay. And then we will do what you want to do, right? So this is actually what we computed before. So let's bring it down. Actually, it's this two thing. Is it this two thing or not? Let me see. Okay, why I miss it? Oh, here. Okay, so let's use what we have computed. So it's this guy here, dy over d theta. Right. So if you want to compute dy over d theta, you need to use the rule. So what is dx d theta? Where did I compute? Did I compute it? Yeah, here. Oh, no wonder I can't find it. So here's dx. Okay, take this one. So put it down here. Okay, so is it okay that I get this? Everyone agree or not? Okay. So what's this this piece here? So how to compute this? Any idea how to compute this limit here? What is cos 3 pi over 2? We computed before. Yeah. Zero. Zero? Okay, zero, good. So how about 1 plus 2 sine 3 pi over 2? So this one go to 0, is it? Okay, let's try it first. How about this factor here? -1, eh? Okay, I believe you. How about 1 plus sine theta? So if this one go to -1, right? Then that means this one go to 0. Is it? Okay, good. How about 1 minus sine theta? 3, huh? Okay, good. Okay, so now there's something 0 above, something 0 below, and then something constant. Constant is nice. It's just that constant. But now you got this troublemaker here. You got 0 over 0. How? L'Hopital. Okay, L'Hopital rules. Okay, L'Hopital rules on these two guys. Okay, so L'Hopital on this. So we get -1/3, and then we want to do L'Hopital on the other two. Okay, so what do you get if you do the L'Hopital? Negative sine over cos. Good. Which is which is what is sine 3 pi over 2? -1. So what is cos 3 pi over 2? 0. Okay. So what do you get? Get infinity. Infinity or negative infinity? Huh? Double negative. Double negative. Correct. So infinity. Okay. So this one actually I want to talk about sine theta, not minus. So I just put 1 because I can move the sign up. Okay, so maybe I put a bracket here. Okay. So this one done. So we can see that if you go from a negative side, you got negative infinity. Similarly, actually you can see that this also go to negative infinity. You can see it by symmetry. Okay. You can use it. You can see it by symmetry. So let's put all these together. This one here, put it back. Okay. So since we know the shape, right? So let's put the shape. Since we know the shape, let's take the shape here. Since this is the last question, we remove this. So let's see what we have. Does it make sense or not? Okay, copy, paste, and then copy this. Okay, see if this makes sense or not. So there are three horizontal tangent and 2 vertical tangent, and then one approaching dy dx equals 0. Sorry, infinity. So let's put it down. So what's the angle again? 3 power 2. 3 pi over 2. So dy dx goes to infinity. Okay, so let's see what we are doing actually. So horizontal tangent at pi over 2. Okay, so we know pi over 2 is here, right? So there's a horizontal tangent. Okay, and then 3 pi over 7 pi over 6 and 11 pi over 6. And then you can see that the radius is kind of the same, half. Okay, so there are symmetry here. So 7 over 6, I think, is in the third quadrant. And then 11 over 6, 11 pi over 6 is in the fourth quadrant. Okay, so you can see that the both here have a horizontal tangent. I think they share the same one. They should share the same one, exactly the same tangent line. Okay. How about vertical? Vertical one is at pi over 6, the other one is at 5 pi over 6. Okay, you can see this symmetry here. The radius is also the same. Okay, so 5 pi over 6, pi over 6, that differ by 4 pi over 6. Okay, never mind. So pi over 6 is at the first quadrant, maybe somewhere here. And then 5 pi over 6 is at the second quadrant, before pi. Okay, so you have some vertical here, and then the other vertical here. Okay, so 3 pi over 2. Okay, what happened to this 3 pi over 2 here? Okay, can you see from the graph what happened? There's a cups here. Okay, there's a cups here. Actually, at this cup, it is not differentiable. Okay, you also can see from the limit, right? When you go from one side, it's infinity. The other side, okay, I didn't tell you why it's true, but it's going to negative infinity. But if you see from this curve here, okay, if you see from this curve here, so if we zoom in a bit more, let's zoom in a bit more. So let's trace this curve out. Okay, just now we see what? Okay, I show you by this limit here. When you go from negative from the left side, you will see that the gradient approach infinity. Okay, so let's see what happened here. So we know that there's one point here, it is a static horizontal. Okay, but when you move close to 3 pi over 2, right, you can see that this tangent line here, what's the gradient become? For example, y equal to x, what's the gradient? Y equal to x, what's the gradient? 1, right? Positive one. Okay. So you can see that this line here get steeper and steeper and steeper, right? Right. So you approach infinity, the gradient. Okay. So by symmetry, what do I mean by symmetry? You can see here, if I do here, okay, if I move from here and then I go this side, right? So this, you can think of it as y goes to minus x. It's not exactly that, but I mean the direction is the same, right? So the gradient is negative. Okay, and then you get steeper and steeper and steeper and steeper. You get minus infinity. You can see that both line here is straight line, right? But one go to infinity, one go to negative infinity. But these two somehow represent the same line. Okay. So is there a difference between infinity and negative infinity? Yes. Yes. So actually, I tell you a fact. In topology, right? If we take this real line, okay. If I take this real line, okay. Infinity and negative infinity is not in the real line. But if I add a add an infinity point here, what I get is actually a something equivalent to sphere. This is what we call compactification. But yeah, just extra stuff that you know. Yeah. So sometimes we don't differentiate negative infinity or infinity. Yeah. Okay. I think we should take a break and then we will go into area. We will finish area today. So let's take a break until 4:21. Huh?
So, since the positive and the positive limit and the right limit and left limit, they don't converge, right? So
Uh-huh.
tangent line doesn't exist. Is it?
Yes. 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 But my point is, you can see that this the limit of this gradient line all converge to one. Yeah, that yeah, actual gradient doesn't. Yeah, actual gradient doesn't exist.
So do we still classify this as a vertical?
Tangent?
No.
It's nothing. It's nothing there, but it's not differentiable at the class.
Can you explain to me the part where you say like you can ignore
Oh,
and on top?
you mean the function? Huh?
Yeah.
Maybe let's use the circle one. Is easier. So, I just want to say, if you look at this bit here, I can use this function to describe every line, every point here. That's what I want to say.
Therefore, like,
Mhm.
so it's more for like dy dx, but one if you make it like dy dt and ds, dt, you don't really have to make it like only like ignore the bottom part. Right? You can use it for every point.
Sure. You can, but the first definition of dy dx, right? Okay. First of all, why can you do that? Okay. The reason you can do that is exactly because you can restrict. Because okay, first of all, because of the definition of dy dx. Okay. dy dx, you need to restrict to where this y makes sense as a function. Okay. But following up what you said just now, why can we like just use this formula and represent every point here? Because this circle here, we can cut it such that every point is a function in this form, where we just change the domain or the codomain. Exactly because this works, so you can just use a single calculation to explain everything. Yeah.
But if we make it like in terms of t or theta, we don't really like need to pay attention to this anymore. Right?
You mean pay attention to the function?
Yeah.
Whether it's a function or not.
Yeah.
Yes, correct.
Don't-
Because yeah, correct.
Okay.
Yeah, correct. Let me think. Yeah, correct.
Because
Correct. Correct.
I was confused about
Correct. Mhm.
which part.
Because when we do the chain rule, right, we already started with a function. So that's fine. Every t have a specific y, x, and y. So that's fine.
Yeah, I was confused about this part why you can use like bigger than I.
No, I mean,
like that's why I thought when no, I mean at some point it goes like and it like so it overlap. And because before I thought you need to like ignore this part or like just use the bottom part and ignore the top part.
What do you mean?
Because at first I thought it needs to be like a function, right? Or like we need to ignore this like in terms of action.
Oh yeah. But I mean, No. I mean, that's the key point we do polar graph, right? So when we make into polar graph, this is a function already. Okay. Yeah. That's the point we do polar graph. Yeah. So we don't need to ignore anything now. Only when you want to go back to xy, you cannot use y in terms of x to describe function as a function. Because one x need to give two y. So you cannot do that. But polar can, because one angle give you one radius. So I mean, it represents every point here as a radius and angle. So you can make it a 1 to many to 1. Not 1 to 1. Strictly speaking, not 1 to 1. Many to 1. So many to 1 still a function. You cannot 1 to 算错了。这样算错了。对，我好像看到了。So actually is okay. Actually 是，诶，这个是OK，这个是这个OK，可以，没问题。
这东西啊，
是
没错，看错啊，对，其实我要这个东西，然后这样做，我上面它都有这个了，这个就等于这个，这个就等于这个吧？为什么我还要这样子嘞
没有咯，只是重做吧。
？OK 了，
很多东西我一直重做啊，就一直 repeat，一直 remind 一下。repeat 吧。topology，对啊，你的题目被人家抢了，我跟你讲。没有他之前那个，不是抢了就赚到了，不用紧啊，赚到也不用紧。这个是什么关系？希望啊。topology，有关 area 的话没有这样子啊。
这两个的 intersection points
不一定，他们 intersection 只是 MD，但是其实我是想说 intersection with axis。
axis，
对，
所以我sketch 两个图，画了
对，你先画先看下他们到底有 intersect 吗？没有
画了一个 system。
啊，当然了，因为你要 find area 嘛。
哦，
对，分开的话你就看不到他们的 area。topology 是什么？study of shape。可是这些 shape 是 classified by genus，就是你讲的动物。喂，我讲的比较像是 algebraic topology 啊，但是 topology 的话是topology in general 的话，structure，topology in general 是它 study local 的 behavior，and then 它 try to 把这些 local behavior 全部 piece 在一起。其实，在 topology 有一个东西我们叫做 open set，就是我们 care about open set，它的 property of 这个 open set。 就是说，如果我 study 这两个一起，这个两个 set 一起，我合在一起，它还是另外一个 open set，就是不管你在这里还是在这里，它都是一样的啊。所以就是 topology 就是 generally 啦，我没有跟你讲是什么，我跟你讲它 general idea 吧。它 general idea 是要 study 它的local 的 information，但是我们要希望这个 local information 可以在另外一个 local 里面也可以 work，所以我们只要 study 一个 local 就好了。它只要 satisfy 这个一个 local，这样我不管我去到哪里，我只要有这个 local 就可以。比如说地球也是个 spherical geometry，但是 locally 是 Euclidean，所以我 locally 这边 work， 那边也 work， 这边也 work， 但是你把它放到 globally 它就不 work。
Okay, we should resume. Oh, by the way, there's some miscalculation. I will update it later. Doesn't affect our concept. Sometimes I talk too fast. My mind go faster than what I wrote, so I will write something wrong. So you should point out. I cannot control two things at the same time. Sorry about that. So, let me see. Okay, let's just go straight into area. Okay, let's talk about area. Area of a circle. Do you know? The computer. Area of a circle. What's the area of a circle? Pi r square. So this is a pi r square. So if I want to don't sign for your friend. I pass this to you. If you cheat me again, I will punish. I don't punish lah. You cannot punish ma. So don't cheat me, okay? Don't force me to do something inhumane, okay? Okay, so pi r square. Pi r square. So we got a circle. Area of a circle is a pi r square. So let's say we want to cut this circle into pieces. Okay, like you want to cut it into you want to distribute this pizza or cake. Okay, so how to find the area of this sector here? Let me redraw this. How to find this? How to find this area? Can you derive for me this formula here? Can you derive for me this formula here? Pi r square times theta over 2 pi. Okay, so the fraction of this area here, okay, what's the fraction? 100% you will get 2 pi. Am I right or not? You like I'm wrong. Is it? Am I right? The okay, correct. So why is it correct? So you have 2 pi angle, okay, but you occupy only theta, right? So you get theta over 2 pi. So you will get this half times r squared times theta if you want to compute the area of a sector. Okay. So you know how to compute the area of sector. Now let's change. Because our curve is not a regular curve. Maybe our curve will move. Okay, let me draw our curve. So maybe our curve will move something like this, right? So what's the area of the region inside this polar coordinate? So instead of a perfect circle, you have some irregular stuff here. Okay, so how are you gonna add this up? What's the tool we need to deal with this irregular thing?
Remember the line, the online classes? Hey, I realized that online classes has more attendance than physical one. Why? You're more willing to listen to the online one.
Online teaching is more effective.
Huh? I don't know it's effective or not, lah, but for attendance, it's effective. Okay, so remember what I say on in the online class. So we only know how to measure this perfect angle, right? So we need to put infinitely many these perfect angle in. Right. Okay. So so what to do? So we need to make this angle, this circle here as small as possible. Okay. It's another integration idea here. Okay. So what we have here is if we have a region bounded by the polar curve. Okay. So here already imply is a polar curve because we write r equals to eta of theta. And then we integrate from an angle A to angle B. The area is given by half integrating A to B of the function radius. Okay, the radius function squared d theta. Okay, so this square here exactly following the formula here. But our radius here is not constant anymore. Our radius changes based on theta. Okay, so we need to make this changes the radius against theta. So square and then put integration. Because we are taking some form of limit where we cut this area into infinitesimal small pieces where you can actually use the formula R squared. Okay. Okay. Yeah. Question. Soon. Oh, sorry. Oh, sorry. Yeah. Okay. Yeah. Okay. So the half here is coming from the formula of area of sector. This square here is also coming from the formula of area of sector. But the theta, is it the theta part? Yeah, the theta part become the integration, become a limit. Okay. Yeah. Okay. I don't want to explain more why this formula come from. Let's use this. Let's use this formula here. So let's start with Limason again. Okay. Looks like a snail. Not sure if it is a snail. R equals to 2 plus cos theta. Okay. Want to find this area here, shaded area. Okay, want to find this shaded area. So where does this area lies in? Second quadrant, good. Okay. Is this area of region in a polar coordinate? Let's see. I think I'm asking some obvious question, but I want to make it non-obvious. Let me see. Can I give you an example? Let me think if I can give you an example. Okay. So let me give you an example. So let's look at this line here. Okay, never mind. I skip this first. Okay. So second quadrant. So where do you need to integrate from? You start from a pi over 2 to pi. Okay. So let's put the formula down. Where? Okay. So what do you have? You integrate from pi over 2 to 8. So this is already to do the second part, sorry. So let's do the second part then. So how? Okay, so we will remember, right? So let's write it down here. Pi over 2 to pi. So what's our radius? Is 2 plus cos theta. 2 plus cos theta squared d theta. Okay, I think this is just a usual integration. What's this integration here? We get 4 pi plus 4 sine theta plus half theta plus sine 2 theta over 4. Is that right? This one is already after integration, so we skip it. So let's skip this. And then what you can do, you just evaluate this, and then you get now we'll add pi over 2. Okay, maybe a bit fast. So I let you try one hands-on problem. Okay, I let you try to find the area of region inside this limit zone. Okay, so the everything here. Okay, I let you try for about 5 minutes. Okay. Just now we integrate from pi over 2 to pi, right? So now you need to integrate everything inside this limit zone here. Okay, see what you can get. You try. Yeah, I let you try first. Try one question in the area. Yeah, I mean, integration for this polar coordinate, right? What you really need to know is the trigo identity stuff, and then know how to integrate trigo function. Okay, so let's see if you will get stuck when integrating the function. Because just now I didn't show you how I integrated. I just show you what's the result. So let's see for this example. See if you can work it out. If not, we can go into detail. For computation itself, right, this question is not really enlightening because if you know where integrating where to where, then this question is basically done. And the next part is only you need to check your accuracy, whether you integrate the right integral. Okay. So let me zoom in. So let you see this question, the function here. So now you integrate from 0 to 2 pi to find the area of the region inside the limit zone. Another thing is your class, I'm not sure why, not not forget the word. Not punctual to the class. I will start the exam, I mean, as early as possible. Okay, I don't want like everyone wait for one person. I think this is disrespectful to the rest, to me also. Okay, please be punctual to the class. I don't know why you guys have this bad habit. I don't know. I seriously don't. I'm really taking note of this. Okay, I think should be almost done by now. So let's check the answer. Anyone have finished or not? Does anyone finish? Want to share your answer? I mean, the final answer is enough for now. Anyone has finished? 9 pi? 9 pi? 9 pi. Yeah, 9 pi over 2. You get 9 pi? Here got 9 pi over 2. You agree? You disagree? Oh, you first divide 2. Okay, so let's agree on 9 pi over 2 first. Okay, let's do the whole thing. So you integrate 4 plus 4 cos pi plus cos squared theta, sorry, theta. Okay, so just now I'm confused with how you differentiate power of cos, right? But really you cannot integrate power of cos directly. So we will make it into a double angle formula so that we can actually integrate directly now. Okay. So in this case, so here I apply trigger identity, right? So this is one of the things you want to keep in your cheat sheet. Okay, so what do we get? Get 4 theta plus 4 sine theta plus half theta plus sine 2 theta over 4. And then you compute this. Evaluate from 0 to 2 pi. I think you should get this 9 pi over 2. Okay. Okay, so this is not the exact fun part of this question. So I challenged my other class, right? Write this limison in the y-x function. Okay, and then do exactly the same thing. Find the area. You know how to find area in xy form, right? Just area under the graph. Okay, this is what I asked them to do. And then they provide me 2 different answers. One is directly do what I say. 2 is they write this into a parametric equation. Okay, you can try yourself if you want. Yeah, there are multiple ways to solve this. Maybe this one is the shortest way. This is the shortest way. So this shows another advantage why we use polar coordinate. Yeah, you can try use the xy function. Try and figure out what's the xy function you need. Or second, find the parametric equation for this parametric curve, and then figure out from there. Okay, so this is the challenge I gave you. Yep, you have a question. What do you mean by that?
What's the angle how to go time and time? How to go from time to time?
Oh, okay. Since you mentioned about this, good. Okay, you mentioned about this. Okay, good. You mentioned about this. So let me try. Let me attempt to answer this. I'm not sure if I correct or wrong. If I'm wrong, right, please refer to Adam. Remember last time I mentioned that there's an orientation problem with the definition. This is exactly addressing that question. Okay, so let me try to explain here. If it is not clear or you want to refer more, please go to the Adam when explaining the integral part. Okay, let me try. Let me try. Okay, so so I think it's a very good example here. I want to show you. So you are being taught that when the area under the curve is negative, right? Okay. But what you are not taught about is it depends on the orientation of your curve. Okay, it depends on the orientation of curve. Okay, so let's start from what we know. Okay, let's start from what we know. So what we know is if I give you some curve like this, okay, area under the curve is just the usual computation. So you can see that this orientation here is going the same direction with x-axis. You can check back all your high school function that should satisfy this. The orientation of your curve follow the direction of your axis. Okay, you can check back all your textbook, all your previous note. Okay, why is it negative? If this orientation is still the same and then move to the bottom part, then it is negative. So let's say if I change the orientation of the bottom part, I go back instead, then this integral will become positive. Okay. Okay. So I think one example you can see is in the Fourier series, right? When the function is so when you integrate sine over the period, I mean the basic pattern here, what's the area? 0, right? Okay, so the top and the bottom cancel. Okay, because you see the direction is going forward when the positive axis is increasing, okay, and then above it, and then above x-axis, and below it becomes negative. Okay, so okay, first of all, see this. Okay, second, you can see here. So let's put back to this example. Okay, let's put back to this example here. So let's say because this is going forward, right? So because this is going here, so what? Let's say this is negative for the moment, okay? Because it's a different convention from what we have here. And then what? And then, but going down, you go the other direction, okay? So they should have the same sign. Either minus minus or either positive positive. So they won't cancel each other. Does it make sense? Does it make sense? Make sense, huh? Yeah. So you want to if you want to refer more, you go to the Adam. The integral, the area integral part. Got more explanation. Stewart don't have. So Stewart, the question given to you is the first type of question. Adam have more questions. But I think I won't test you on this thing. Okay, so this one is the extra knowledge. So if you go further study, right, you will see this. Okay. Actually, there's an interesting part on this area, right? So why wave can keep moving like this? It's like conserving something. Plus, minus again, plus, minus again. So it's kind of a balance. If it is plus, then it will like go nowhere, go astray, like go to don't know where, right? So but it keep repeating. And then when you see, you also feel calm, right? So I feel calm because there's nothing changed here. Plus minus again, plus minus again. Okay. Yeah. That's what I'm saying. Yeah. I mean, when I read about this integral area thingy, right? So I think about this sine function, and then I think kind of makes sense. Kind of makes sense. Kind of makes sense. Okay, that's an extra thought. But you can read about this Adam part. If you don't understand, maybe we can sit down and read again. Okay. Okay, good question actually. Very good. Very good question. Okay, so next part. So find the area of one leaf of the 4 leaf rows. R equal to cos 2 theta. I think they computed for you already. What's the angle? So how to count this 4 leaf? Well, how to count this area, bounded area here? What's the integration domain here? Okay, pi over 4 to pi over 4. Okay, to save time, right? I don't want to do this calculation in now, so I just give you the answer. 1 over pi over 8. But actually, there's another way to calculate it. There's another way to calculate it. Why? Okay, you see, the way you guys answer my question, right? You just straight away give me the method. You don't tell me why one. I actually don't care your final method, okay? I just care how to solve it. So why you can integrate 0 to pi over 4? Why you care about 0 to pi over 4? That's the thing that I want to hear. I don't want to hear how to do it. I want to hear the exact method. I want to hear why. So why you care about 0 to pi over 4? Can you tell us? Sine 2 theta, cosine 2 theta is an even function, and then okay, so let me draw it up. So just now we have pi over 4 to minus pi over 4. So something like this. Okay, so you're talking about this. So you said that cos 2 pi is a even function. Okay, very good. Okay. And then you say because it's even, so what? Ft equals to minus Ft. Is that right? Okay, I think I do something stupid again. So this is a sine. So I need a cos. So the cos looks like, where's my eraser? So the cos is something like here, and then here. And then what? It's symmetric. Okay, symmetric across where? Y-axis. Right. So it's symmetric. Did I speak wrong? 2m, huh? 1m or 2m? 2m. Symmetric across y-axis. Okay. Yeah. So this is how you explain in your assignment. Don't straight away give me a equals to 2 times integration 0 to pi over 2. Okay. So you say since this function is even, okay, and then we can see that it is symmetric across x equals 0. Okay, y-axis x equals 0. or y-axis. So we can just compute a function from 0 to pi over 4 and then multiply by 2 and then show the calculation. Does it make sense? Okay, this I need to get the flow. Okay, why you do this step? Why you do this step? Why you do this step? You should have a flow in your mind, right? Just you don't explain it. Okay, so you need to learn to explain what you are thinking. Yeah. Okay. So second method, you can use symmetry. Okay. So in this case, you see, I not only can integrate 0 to pi over 4, right? I also can integrate minus pi over 4 to 0 times 2. Also can. See? So yeah, so the argument is more important than the actual calculation. So if you just say, I integrate from 0 to pi over 4, multiply by 2, because then done. Then the other people ask, how about minus pi over 4 to 0? Can I do that and then multiply by 2? Can. Both can. Why? Because the function is symmetry across the y-axis. So you explain everything already. Right? You get the idea. Okay. Yeah. So university level, right? You care about why we do it, not just how to do it. Okay, you need to set the rule for people. Okay, don't find rule to follow anymore. There's no rules here. Okay, a bit a bit how do I want to say? Okay, so maybe sound a bit, what's the English word? Malay word is biadab. What's the English word? Impolite, huh? Impolite. Rude. Yes. Although it sounds a bit rude, right? Yeah, I let you think about it. Sound a bit rude, but I let you think about it. So you have to make the rule. You have to make the rule. The future is governed by the young generation. All generation will be gone. They will die. They will die with their own rule. We have to set our own rule. To set the rules, you need to know the principle. So you need to know why people are setting this rule. Why this rule makes sense. And then see if you can find a better rule. Everyone keeping already. Want to do a related question or not? Related to what you guys did. Okay, maybe we just talk about how to find it and then we don't do the calculation. So the question here is find the area of the region outside the cardioid. R equals to 1 plus sine theta. And inside the circle R equals to sine theta. Okay. So in the assignment, I don't give you this diagram here. I ask you to draw because I want you to practice the R theta plane to XY plane thingy. Right. So you need to draw this diagram yourself and then determine what region you want to find. Okay. Let's say this is the second part already. So already drawn the graph. So now determine what's the area bounded by these two curves. Okay. Not any area is outside the first cardioid and then inside the second circle. So what do you do? Any idea on how to do this? First of all, let's say these 2 points are not given, right? These 2 points are not given. So how do you find this 2 point here? What is this 2 point referring actually? The intersection, okay? The intersection. So if let's say these 2 points are not given, how do you find it? Find the intersection. Again. So what are you doing actually? So you are equating two curves. Okay? You are equating two curves. Okay? So you are equating two curves. So you let okay. So be precise, we let R1 equals to first cardioid, R2 equals to the circle, and then we consider R1 equals to. So we consider R1 equals to R2, and then we solve for theta, and then we will find that this is the two theta we need, theta 1 and theta 2. So what's next? What's next? How to find the area of the region? What's next? Yeah. What do you mean? The texture. Hey, good, very good. Good. So we have theta 3. Okay. So from the diagram you can see 3. Maybe when you solve it, you can see 3. Okay. So from the diagram we see 3. So we eliminate the origin one now. Is it? Okay. So that's fine. So let's say we got these two angle here. So how do we find the area of the region? Any idea?
Let's find the region of target and then minus it.
Okay. So I mean, when you say area of the region, right, you need to have some bound. Do you want to compute everything? Okay, so that means you take the, okay, let me use a color. So if you just look at this circle here, right, okay, if you take the bound from these two angles, the area bounded by the curve is everything inside this. Yeah, maybe this one doesn't look good. So take this one. Okay, right? Okay, but you don't want the white part. Okay, what's the white part actually? The white part is the area bounded by the cardioid. Okay, so really you need to take away the, let me put green part. Okay, so that what you left with is the shaded region. Okay, does it make sense? Any question? 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 No? Question? Question? Okay, actually what I taught now, what I teach you just now, what I score Mingxiu just now, right, is Western style of learning. Okay, so you guys, okay, not you guys, I mean, at least for me, okay, I also grew up as an Asian country, so it's like Asian philosophy. So you just do, calculate, and then when I go to university, we have a mix. I also suffer a bit from the culture change. Okay, so we are kind of in the intersection between the Asian or the Eastern culture and the Western culture. This has a benefit. Do you know who is the dean or HOD for the? I mean, in this school we call HOD. Do you know who is the dean of mathematics department in Harvard? Anyone know? In Harvard University, you know who is the dean for the mathematics department? You don't know. You guys know. Chinese people should know. You don't know. Yes. Xin Tong Yao Xin Tong is a Hong Kongese. He solved a famous conjecture and then create a metaphor called Calabi-Yau metaphor used in string theory. So it's an agent. What he received for his education is he also received the Eastern education before university, and then after university he go to Berkeley, UC Berkeley to do PhD. So this is the, I mean, there's a good product for this intersection of culture here. Also, the one of the Nobel Prize receiver, a Chinese, Chen Ningyang, Yang Zhenling, Chen Ningyang. Also, I think bachelor he's doing in China, and then also US go to PhD, PhD go to US. Yeah. So you guys need to blend these two skills well, then you can succeed in whatever you want to do. Okay, so you got a practical skill, you got a hand-on skill. Then what's the next is you need to express your thinking well. Okay. Okay. Okay, I'll let you go. Okay, see you on Friday. So remember to hand in your assignment tomorrow night.
đấy. Thì sao?